Yo guys, welcome to another video, and here I want to tell you there is another lesson. So as we talk about Adam in previous episode 1 and episode 2 with the title "What is the smallest thing in this entire universe?" We have done it. Hooray! So we'll continue on a lesson of element, compound, and mixers. And then make sure you subscribe, like, and share. Done? Let's start. So first we will review about we talk about atom in episode 1 and episode 2. We know that atom is the smallest thing that made everything we know in this entire universe and have smaller part called subatomic particles. It is proton, neutron, and electron. Structure of an atom and number of proton inside of it is the one who make different elements. So if there are more proton inside there are there are more proton like in an atom in an atom in an hydrogen atom there is just one single proton atom and electron. So if I added a proton and a neutron, so the proton become two and then there is neutron to form a nucleus, it not become a hydrogen anymore. It will become a second uh, table periodic element or heavy. So a structure of an atom and number of proton inside of it is the one who make different elements, while electrons, while while electrons number in the structure of an atom will make the atom become an ion by its number. So if there are more electrons, it has become a cation, an anion. But if there are more protons or the electron is much more is less than protons, the atom become a cation. So uh, the number of an electron, the ion, the positive and negative ion is depends of how much the electron is. And then neutron change the mass of an element that make that was that's still a same element, but if there are more neutron, the atom will form a heavier strip or a more higher level of an element. This is called an isotope. And then atom also lost and accept electron to change their ion charge. Atom bonds together with another atom and form molecules with covalent bonds or sharing electron. But what is actually atom that can form billions of things in the entire universe? So differences between element, compound, and mixtures. So I will tell the definition of element, compound, and mixtures, and then you will see and you will know the difference automatically. And then, what is an element? Element is the most fundamental thing that made everything we know. Each element have different atom structure and forming of just one single atom. So, element is what we know as an atom. Uh, the number as I mentioned before, an element can become different if we add more protons. So if there are two protons, the uh, the element become two also. They have atomic number two, or we know as helium. So element is the most fundamental thing that make everything we made. What make elements different each other is proton, neutron, and electron inside of it. So element is something that made from a single one atom, but an element is depends by how much the proton is. And so you know what is an element? Element example is nitrogen, hydrogen, helium, carbon, oxygen, and many more. And then there is compound. Compound is state when each element bonding together to forming molecules. There are homogeneous and heterogeneous compound. But what is homogeneous and heterogeneous compound? So compound is where the is when there are two or more, there are two or more an element. So uh, in a compound, there is two or more elements that bonding together to forming molecules. So it is not just two, but it can become three, it can become four. And then there are homogeneous and heterogeneous compounds. Homogeneous is when a same element forming together uh, to form a compound. So if there are a hydrogen and then there is a second hydrogen, they will form together to become a compound. But this compound is forming by the same element, so it is a homogeneous or forming by same element. But heterogeneous is the opposite. Heterogeneous compound is where there is many diverse elements in that compound. Okay, and there is a mixtures. What is mixtures? Mixtures is state where many compounds joining together to form very complex things, such as our body and plants. Even our body itself, like bone, is forming by calcium, and then red blood cells and white blood cells. Uh, few of them are all made up of zinc, and then what happened to our muscle? What making them, it is very complex, and it is a mixtures, it is very complex mixtures is state where many compounds join together, not just two, it can become three, four, even 100 to form very complex things such as our body and plants. There is magnesium in a flower, and then there is many more, and oxygen, and then anything. Okay, so this is an example of an element. Element, like we know, hydrogen. Hydrogen is just a single structure atom that consists one single proton and one electron. So hydrogen is an element that only have one atom. So what happened in a compound? So compound H2O, or we know usually in the daily life as water, H2O is a compound where two or more elements joining together. There are there are two hydrogen and one oxygen. So because there are more than one single hydrogen, it is become a compound. And then there's a mixtures. If you know what is a salt water or seawater, that it is actually water, it's an H2O, but it's different because it is salty. What makes them salty is because they are mixtures and have another compound inside of it. So in salt water, there are an H2O and not sodium chloride, or we know as table salt. So table salt mixed with uh, water will form salt water or water in the sea. Next. So this is a table periodic of element. There is 118 uh, element in the universe, but some of them cannot form naturally and just can form in lab or in very rare circumstances. And then there is a hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. They have same color. This means they are uh, all of them is one type. It is called other non-metal or yep. So I am I have a conclusion. So hydrogen, carbon, nitrogen, oxygen, sulfur, phosphorus, and selenium is a, a type of group that hydrogen, carbon, nitrogen, oxygen is the most element that form many things like hydrogen. Hydrogen can form water or uh, vinegar with carbon, C C H C O O H. So oxygen, carbon, and hydrogen is forming together, and they are common element that found in compound. And then nitrogen also found in ammonia or NH3. So they are the most element that can form compound. And then there is noble gases like helium, neon. argon, krypton, xenon, and radon. So they are five. No, there are five noble gases. So helium is just one single atom, and they cannot found in any compounds or any mixtures. So helium cannot bond with another atom to form a compound. So we cannot find a helium compound or a helium mixtures. Helium is just stand itself. So you will find helium is in its own state and not in a compound state. It is also happen in neon, argon, krypton, xenon, and radon. They cannot form together, uh, not like sodium, potassium. They can form together uh, to to make a compound. And helium is the lowest element that cannot form compound. Okay, and there is alkali metal, alkaline earth metal, transition metal, and post-transition metal. I will not talk what it is, but this is a metal. They are making the most biggest place in the periodic table. And then there is also a metalloid. So why I'm not including metalloid in a metal group? So as a transition metal, it is a metal. This is a metal, but they have different structures and type. But metalloid is 50-50. They are not a non-metalloid, but they are not also a metal. So they are a half of metal and half of non-metal. They are in the middle between it. So boron, silicon, germanium, arsenic, antimony, and tellurium is a metalloid. And then there's also lanthanide and actinide that this is also a metal, but they are radioactive and cannot we cannot find it in a nether. We cannot find it naturally. Usually it is formed in laboratory. And then there's also a halogen that very uh, radioactive like chlorine, bromine, iodine, and astatine. Fluorine is not. But fluorine in a state of an element is dangerous and toxic. But fluorine is used in our toothpaste, and yep, it is. But why they are not dangerous? Because sometimes an a compound can neutralize each other uh, so not sodium chloride will form a table salt, but chlorine is already active and dangerous gases. Oh, I'm sorry. Wait. So sometimes a compound can neutralize its element, uh, its element trait, or its element. Um, so sometimes a compound can neutralize its element character, because when you see a sodium chloride, I will repeat, sodium chloride, they are uh, chlorine itself is very dangerous gases and radioactive. So if we consume it in an element state, we will die. But when they are mixing with sodium and chloride, the radioactive and toxicity of chlorine is neutralized by sodium. And then they will make table salt that we eat every day in our food. Okay, and what is an unknown actually? So in an unknown, there is just an element that have no character. They are just they are just empty. So let's continue. And then we will talk about element, type of element, and what is his character and what is the. So hydrogen is the most valuable element in this entire universe. 78% of this universe is hydrogen gases. So hydrogen usually form in gaseous state in a room temperature. So what is mean a room temperature is uh, actually our how we feel temperature like in a day, in the daytime. What is the temperature? Maybe 70. Oh wait, maybe 30, 35. So the room temperature is between 35 and 40. So in a room temperature, or we feel in a daily life, it is formed in a gaseous state and only can become solid in a very cold temperature near absolute zero. What's absolute zero? We'll talk it in another episode. And then hydrogen also form together with an oxygen to make water, and then an H3 and to form an ammonia. And then this hydrogen used to be, or become a rocket fuel because hydrogen is flammable, and this means hydrogen can form to become a fuel of a rocket that make the rocket can fly, and then they will make a methane or methane and ammonia. So this compound is used is very important in an industrial in the industrial job. And then there is helium. Helium is the lowest element that can form with another atom, as I mentioned before. That means helium cannot form with another atom to form a molecule. But helium in an element state can use to fill a balloon, that it is making balloon fly. And then the helium also uh, the one who make hydrogen, a liquid hydrogen that will become a rocket fuel, keep liquid. And then helium also used in medical purposes such as respirator, to make a reaction, and then and then etc. And then there's also oxygen. Oxygen is one of the gases that forming Earth's atmosphere. Oxygen is the only gas that we can use to breathe, because we cannot, uh, if we breathe radioactive and toxic gas, we will die. So the only gases we can breathe is oxygen, and maybe sometimes we can survive when we breathe with nitrogen or hydrogen, but it will not uh, still long, because we will die if we keep breathe and breathing nitrogen and hydrogen. Oxygen also make a process called oxidation. What's oxidation? We will talk about it. Okay, compound. So oxygen make compound like carbon dioxide and copper oxide. So this copper oxide is copper uh, that have oxidate carbon. Carbon is formed many types of mineral in the earth, like diamonds, like graphite. And then carbon is usually formed in a solid state in a room temperature. So compound that carbon made is CH3COOH or a vinegar, and there is C6 H H9 and O12 or carbohydrate used to paleontology. What is paleontology? So paleontologists use carbon footprint to analyze the fossil, like fossil dinosaurs fossils or another or anything. So uh, the paleontologist can know what how old this fossil by use a carbon footprint. And then carbon also used in lighting fuel. So as we know, coal is is the uh, mineral resources that we used until now to become the most and then it can make a large amount of lightning and that we use in everyday life. So lightning fuels is forming lightning is forming uh, one of them is coal, and coal is formed one of them are carbon, the element that also help forming coal. And then the black color from ink coming from carbon, And then there's also nitrogen. With oxygen, nitrogen also making Earth atmosphere and the most valuable gases in the Earth atmosphere. Nitrogen is easy to explode, like what happened in the Belarus when ammonium is nitrate is explode. So it is used in industry and become an explosive thing. And then nitrogen make an NH3 or ammonia, and then many others. And then nitrogen also used to make fireworks that actually pretty safe and bomb like we used in a war. And then uh, an army that we have that they have to use a bomb to that explode to knock the enemy. Like you know, if you are playing battle royal game, and then the nitrogen also help making dyes and fertilizer. So the nitrogen, the liquid nitrogen, is very cold and can make a fertilizer that can keep the food, uh, can make the food still cold, stands cold. And then there's iron. Iron is the most well-known metal in periodic table with gold. Iron is a heat and lightning conductor. However, iron is easy to rust or oxidate. So oxidate is a process, and the rusted is the result of is the result. So an oxidation is a process, and then the result is rusted. Iron is a pure substance, and its atoms join together with metallic bonds. So they are not doing covalent bonds. What is metallic bonds? We'll talk about it. And then uh, uh, iron used in architectural industry that I cannot say one by one. So when you have a spoon or a knife or fork, it is forming with uh, iron that mix with copper and then with aluminum too. This is called an alloy. Okay, next. So as I mentioned before, there is metallic bonds. So the bonds is not actually just covalent bond. There is also metallic bonds and ion bonds. So there are 71 metals type in periodic table, but usually we know some of them in the transition metal, like copper, iron, zinc, cobalt, and gold. And they are forming different than another type of an element. In metal molecules, they are not forming by sharing their electrons, but electron in a metal molecules are moving freely between the ionic metal atom. So between the cation or anion atom, the anion or cation uh, element, camp element, uh, element what? Just ignore. So in metal molecules, electrons are moving freely between the ionic metal atom. It can moving freely in a cation or in an anion, and then electron inside will not leaving the molecules. It will not throw away because it has strong attraction than the covalent bonds. So the covalent bond is by sharing their electrons, but the metallic bonds is much more stronger because the electron itself is moving towards everywhere, and then it will make uh, it will make the more the metal become more solid, and then uh, the metal become have much more stronger structure than a compound that forming by covalent bond. And then there's also an ionic bond. Different from metallic bonds, ionic bonds are joining together because of the law of electromagnetic that make negative atom can join positive atom. Because of it, ionic bond. are structurized in a giant structure that consists anion and cation on. So, because first a cation atom and an anion atom will attract each other, and there is another cation and another anion, and that will make a there will make a very structurized atom in a giant structure that consists anion and cation on. Ionic bonds is so strong and in a final state, the molecule become neutral, cause the same amount of cation and anion. So because a cation and anion are bonding together with another cation and anion, it will become much more strong. Okay, next. Separating compound from mixtures. So there are six ways to separate a compound from its mixtures, like how we can separate table salt from the seawater. How can we get? I just want the table salt. I don't want the water. How can I get the table salt from the water? So there are ways called evaporating. To separate salt from the water, the thing we do is put them on the ground, and then in a few hours the water all gone because there and then there are just table salt because the water is evaporating. So because the melting or the because the water is have a boil a much, so we know that water itself in room temperature is liquid and then salt is solid. So to make salt evaporate, it will take much more longer time than water that have become a liquid. And then the boiling point between the water and the salt is different. So the water will evaporating first and the salt will not evaporate. It will leave the salt behind. And then there's also centrifugation process. If I told you that we can unboil an egg, but how? So if we spin a solid egg in a high speed, we can unboil an egg. So if we boil it and then our kid don't want an unboiled egg, we can unboil an egg because of centrifugal and centripetal effects that make their bond match up. So uh, temperature can make the atom bonds become more active, and it makes the atom have no internal structure the more liquid and the more gas it is. And then uh, if I'm also spinning them, their molecules will vibrate, and this will make uh, an egg can become a liquid again, because uh, we can freeze it, it will become more solid. And if we boil it again, we will not get they are just still solid. And then there's also a filtration. You are always do this if you are noodles eater. This is a easy example. So when you want to separate the noodles from water, you filtering it. And then you can also separate a soil that contaminate the water using sponge, stone, and carrot. So the compound that leave behind called residue, and then the water that can get through sponge, stone, and current. And then after get through three of these, they can become a pure water. It will become white again because the residue, the soil, will leave behind and cannot enter the because the soil cannot get through the the whole the sponge, stone, and cotton's pores. So just water can get through it. So it will leave a residue behind and filter it as a water. The water is a filter. Away. And then there is also a process called chromatography. This method is used by cops detect drops from people's urine by using color and light to detect what compound is in the urine. So, to know what is compound in the urine, because urine is a mixture, we can know it from a process called chromatography. So, uh, if there are a special paper that we can use for an indicator. So, uh, when the when the when the different compound, so from a mixers, a different compound will make a different color, and how fast they travel in that paper. So if they are slow and the color is what, so the compound is A. And then if the if the spread is more rapid or more fast, and then the color is red, so this mean that was a, an X compound. So we can know what is compound inside of the mixtures by using color and light to detect. So there are also process called distillation. So distillation have same principle like evaporation process. This process is work because melting point difference, not boiling point in a liquid ion. Boiling point too difference in a liquid state to get other liquid. So if a liquid were contaminated with other liquid, how we can separate them, because it will become very hard. We cannot evaporate it, but we can distillate it. We can get oh, uh, we can get the compound that we want to use. So distillation and sublimation. This is hard to explain, so I just skip how they are work. And then there's also sublimation. This process is using to get a compound from another compound that can sublimate like camphor. So if camphor is contaminated by sand or vice versa, we can uh, separate them with a sublimation process, because camphor will slowly sublimate. So yeah, that's all from me. Enjoy and bye.